Hi, this is Leetcode question. Maximum strictly increasing cells in a matrix. This is the last question of weekly contest number 347. In this example, the maximum number of cells is 4. We move from minus 9 to 3, from 3 to 6, and from 6 to 7. So in total we have 4 cells, and this is the maximum. To solve this question, what we will do is to find the solution for the cell with the lowest value. Then we move to the cell with greater value, and the reason for that is, assume we want to find the solution for 5 and we know the solution for all the values less than 5. So what we need to do is to look at the cells in the same column and the cells in the same row, and we take the last or the maximum values among all of those solutions, and we just add 1, and that will be the solution for the value 5. And to do that, we have this vector of values that stores 3 things: the value in the grid and its location in the grid. So we have values stores 3, the value at 0, 0, and we have 3 at 0, 1, then 6 at 0 or 2, then minus 9 at 1, 0, then 5 at 1, 1, then 7 at 1, 2. And as we said, we need to find the solution for cells with the lowest value, then move to the cell with greater value. And to do that, we sort this value vector based on the values. So after sorting it, first cell is minus 9, 1, 0, then 3, 0, 0, then 3, 0, 1, then 6 or 5, 1, 1, then 6, 0, 2, then 7, 1, 2. And as we said, for example, if we are finding a solution for the cell 5, we need to look for the cells at the same column and the cells at the same row. And to do that, we need an efficient way and efficient data structure. And here I use a vector of sets for rows and columns. So rows has 2 rows, 0, 1, and columns has 3 columns, 0, 1, 2. Each one of these is a set of pairs. These pairs will contain the value in the grid and the final result, which is the maximum number of cells to reach to that cell. So we start from the first value, or the first cell. It's minus 9, 1, 0. So we have value minus 9 and row 1, column 0. That's what we are doing here. So row 1, we look at row 1 for first cell that has the value equal minus 9. In this case, the set is empty, so the result will be 1. This condition will not enter. And column equals 0, the same, we look in this set, but this set is empty, so the final result is 1 for this cell. This cell exists in the first column and in the second row. So at row 1 we push the pair of the value, which is -9, and the final result, which is 1. The same for column 0, we push pair of -9 and the result, which is 1. Then we move to the next cell. We have the value 3 at 0, 0, the row 0. So we look at row 0, again it's empty, so lower bound is doing binary search in C++. And remember, set also store the pairs in sorted way, so that we can do the lower or binary search. Now we said 300 at row 0. We look for the value 3, but this is empty, and that means the result is 1 in this condition. Also we look at column 0. So column 0, here we do lower bound for 30. This will return the pointer to the first cell that equal to 3 or greater. In this case it will return pointer to the end of the set, and this is why we do here minus minus. So after minus minus, the pointer becomes to this cell, and this is what we need to do, or this is what we needed, because we can go from -9 to 3. So what is the result at -9? It's 1. So we have 1 plus 1 equal to, so the final result here is 2. That means for this cell the result is 2, and we store this result at column 0, or at first row 0. So we have 3 and the final result is 2. Also at column 0 have 3 and 2. Then we move to the next cell, 301. We look at the first column, or the first row 0, for the value 3, 0. At this case, the lower bound return pointer to this node, but we do minus minus, so if we do minus minus, it will go out of the set. This is why we check here. If this pointer is the begin, that means we cannot go from 3 to 3, so this condition will not enter, and the result stay 1. Now we look at 1 for 30. Column 1 is empty, and so final result for this cell is 1, for this condition not enter, and we store this result for in the first column. So here we have 3, 1, or in the first row, and second column. So here we have 3, 1. Notice that this is 3, 1 comes here because this is a set, so at the end it should be sorted 3, 1. Then we have 3, 2, because we have set here. Then we move to the next value, 5, 1, 1. 5, 1, 1. We look at this row for the value 5, and we return pointer to the end of this. We do minus minus, so the pointer becomes at this node. So from -9 to 5 we have 1 plus 1 equal 2, so this if condition return 2. And we look at the column 1 also. For 5 to return pointer to the end, we do minus minus, so the pointer will be here 3 1. That means we can move from 3 to 5, and here we have 1 plus 1 is 2, so final result for 5 is 2. And we push this to 1 1, so here we have 5 2, and here we have 5 2, then we have 6 0 2. So row 0 we look for 6, so there is no 6. Return pointer to the end of the set, we do minus minus, so this will be the cell 3 2. Now the result is 2. 2 plus 1 is 3, so 3 from this condition. That means we can go from this to this, and the result will be 3. Column 2 is empty, so this condition, this if not be entered, and the result will be 1 here, and the final result will be 3 for this cell. So again we push to column 2 6 3, and to row 0 6 3, and so on. The last one is 7. It will be the last, or the final answer will be 3 plus 1 equal 4. Notes here, I stored many values. For you might need a better way to just store the last value, but this solution should work.